Okay, so we're looking at domain and range today, and you'll notice it says set builder notation. We're doing 2 days of domain and range. Tomorrow we'll learn about a different type of notation, still for finding the domain and range. So the domain is the set of the independent elements in a relation. And so typically those are the x values. Okay. Independent variable, you can put in independent variable elements. You can call those the first elements. So if you're talking about ordered pairs, it's the first value in that ordered pair. Okay. Range is the set of all of the dependent variable elements, which are really the second values if you're looking at sets of ordered pairs. Okay, and so those are typically the y values, unless you're doing an application question, right? Obviously, it could be something different. We talked about discrete data last week. That is where we can only take specific values. You can't have part of a value. Now, discrete could still be a decimal, could still be 1.2, 1.6, 2.0, etc., but not all the values in between. So it doesn't mean that it can't be a decimal, but it means that it doesn't go on forever. So recall that discrete data can only be taken at specific values, where continuous data represents data that is within a given range of values. When data is displayed graphically, discrete data is displayed as plotted points, whereas continuous data will have the points connected. Based on whether the data is discrete or continuous, we will write the domain and range in different formats. So we'll look at 2 different methods. As I said, today set builder, tomorrow interval notation. Okay, so discrete data is pretty easy. You just list them. Okay, so when writing domain and range for discrete data, we simply list the elements in set notation, separating each element with a comma. If it's numerical, we typically list the values from least to greatest. If elements occur in the relation more than once, we only list each element once. Don't repeat them. Okay, so we're going to state the domain and range here. Now, another way of thinking about domain and range, think about X and Y. What comes first in the alphabet? X. Okay, think of D and R. What comes first in the alphabet? D. So D goes with X, right? Domain are the X values, range are the Y values. Sometimes students get them mixed up. So domain or first values here. So we just go D equals, and then squiggly bracket, I call it, and we list all the X values. So -3, -1, 0, 2, 5. They're already in order, which is kind of nice. And then we close the squiggly brackets. Range, 4, -2, 5, 4, 8. So I'm going to put them in order. So -2 is my smallest. And then 4, notice how it's here twice. I'm only going to list it once. You don't go 4, 4. Okay, just once. So we've got that. And then 5, and then 8. Yes. Okay, sometimes our relation isn't always numbers. So for the next one, our domain is John, Kelly, and Jeff. And our range is, I'll put them in alpha order, in numerical order, 7, 8.5, 10. They don't have to match up in that order, right? They're separate statements, domain and range. Nice thing about an arrow diagram is usually when you make an arrow diagram, you should put the values in increasing order. We've got names here, so that's just, I'm going to list them as is. So Tim, Jim, Sharon, Cal. Range, they're already in numerical order, which is kind of nice. 65. And even though it has units, we don't put the units in the domain and range. Okay. And then a graph here, again, this is discrete data because it's just points. So I'm going to look from left to right. And the first point on the left has an x value of -3. The next point, an x value of -2. Next point, x value of 0. Next, x value of 1. Next, x value is 4. Range, I'm going to look from the bottom up. So the lowest is -3, then -2, then 1, then 2, then 3, then 5. Okay.
Are all of those functions?
Oh yeah, we have to state whether they're a function or not, don't we? So we want to look back at whether for each domain there's only one range. So the graph is a nice thing to look at here. And so remember, if there's, for an x value, if there's two different y values, then it is not a function, right? So for the x value of 1, there's two different y's, so that is not a function. With an arrow diagram, it's also easy to see. There should only be one arrow coming from each domain if it's a function. Okay, and there is. There could be two domains that go to the same range, but not one domain going to two ranges. So this is a function. This is a function. They're all different. And then here, for each domain, so you want to look, basically look if there's a repeated domain value. That would be what you want to look at and see if there's two different range values. Well, there aren't any repeated domain values, so this is a function. Okay, so even though there were two y values of 4, that's okay, because that's basically saying there's two horizontal points, but not the other way around. Okay, so that was for discrete data. Now we want to look at continuous data. We need to remember our inequality signs. So this sign here without the line underneath means it's just less than, okay, rather than down on the third row would be less than or equal to with the line underneath. Okay, so if it doesn't have that line underneath, it doesn't include it. The other one is greater than. Okay, students get those mixed up. You read a book from left to right. You read your sentences from left to right. So if we have this number, say something A is this symbol B, then A is greater than B. I think about it as Pac-Man eating the biggest thing, right? Or in junior high, sometimes they talk about an alligator, right? So it opens to the biggest number, but we read from left to right. So this one's greater than. Here, A would be less than B, because the small end is next to A. And then when we've got the equal to, we have to have the equal underneath. Okay, so next thing is to draw a number line on a number line, x greater than or equal to 5, and then on a number line, x less than -1. That's not so straight. Just a sec. Okay. So you want to, on a number line, plot 5. Okay. It's understood that here, this would be if we wanted to show more points, 0 would be to the left. You always put the smallest on the left, largest on the right, and obviously it would be getting bigger. So these are your, so here that would be 0, this would be -1. And you could have more points. Now, if we want to draw all the values of x, so these are what we're drawing for x, that are greater than or equal to 5, then we do a closed circle on 5, and we have to go to the right. So oftentimes we go up a little bit and then draw the arrow so that you can see it. If you do pencil on top of a really dark number line, I might not be able to see it. Okay, so that's x greater than or equal to 5. Here's a bit of a trick. If you've got the x on the left like it is here, then that inequality sign is the same direction as the arrowhead. That helps. Here, if x is on the left, then the arrowhead's going the pointing to the left. So this would be an open circle because it doesn't have an equal sign going to the left. Okay. Now the next ones, you can see them in red. They're not in red on yours, but hopefully you can see them filled in. We have to come up with the inequality. So if there's 2 endpoints, like there is here, then I think about, okay, what are those 2 endpoints? -3 and 4. And I write them out in order with space in between. Then if I'm, it doesn't say what variable, but let's assume it's x. So I'm going to put x in between, and then our inequalities have to be opening to the right. It's going from smallest to biggest. Okay, and they're closed circles, which means I need the equal sign. Okay, so that's the inequality represented by that number line, the red part of it. Over here, I've got -3. Okay, and it's opening to the right. So you might think, oh, okay, this is less than something, right? Well, this goes on forever. So all of these points here are greater than or equal to -3. So that means x is greater than or equal to -3. And so now you can see how the arrowhead direction is the same as the inequality there. These are closed circles, so we include the equal signs. Okay. So turn over the page. And now we're getting into actually writing domain and range for continuous data. So when writing domain and range for continuous data, we have to do more than list the values. Basically, you cannot list all the values. Okay, guys at the back, off the phones, please. Pencils in your hand, doing these. Okay. Same at the front. Same at the front. Same at the front. Phone away, please. Away, away. How about a pencil in your hand? Okay. And then turn to the correct page. All right. So we have to do more than list the values. We need a way to fully describe them. Below is an example. So notice domain, colon or equal sign, I'm not really picky on that, but we use those squiggly brackets, but this is what you have to put in there. And you say, why do I have to do that? It's the proper notation. It's what is known as proper notation for domain and range in set builder notation. So you put an X if that's the variable you're using for domain. And then a vertical line there is the such that. So I say it, all the values of X such that X is an element of the real numbers. So see that funny looking E? It's kind of like a C with a line in it. So it's a rounded E. It's a Greek symbol for E. So that means the element of the set of real numbers. So that real numbers, remember, include every value possible. Decimals, fractions, repeating decimals, non-repeating decimals. Yep. Infinite in both directions, negative and positive. Then here, this is range. So you can see that if I extend this down, all real numbers forever for X's and both directions. For Y's though, there is nothing above the X-axis. So Y has to be less than or equal to 0 because both of these ends are going downwards and it's continuous. We still have to put in that it's a real number. It's just the notation that you have to do. Okay? If you don't, then technically maybe someone might think that it's integers or natural numbers, so you have to put in that Y element of set of reals. So we would say this, all the values of Y such that Y is less than or equal to 0, and Y is an element of the set of real numbers. Okay, so that's what we are going to do ourselves. So take a look at this graph here, the domain. So you want to think about, okay, on the X and Y axis there, are there any points here?
No.
No. So there's no value, the smallest X value you can have is at -3. Then these arrows go to the right, all of them. They go to the right, it's every number greater than or equal to -3. So it's inequality with one boundary, I call it. I just a sec, I gotta, just a sec. I don't know what I did to, there we go. Okay, so D, so squiggly bracket, X, vertical line, X is greater than or equal to -3, X element of the set of reals. And I use that double line for real numbers just to be the set of real numbers. Now, because that's the notation. It means all the values of X such that, the vertical line is such that X is greater than or equal to -3. Range, so take a look at this. This arrow is going up and to the right. This arrow is going down and to the right as well. So vertically, it's going up and down. No gaps in between. If you say that to yourself, up and down, no gaps, it's all real numbers as well. If I expand that out, it's going to end up going to infinity in the positive and negative direction. So that is just range Y, all the values of Y such that Y is an element of the set of real numbers. No inequalities needed for that. Okay, now, hands up. Function or not a function? Okay, there's no hand up there. Yes, it's not a function. Do that vertical line test, right? If it touches twice any vertical line, it is not a function. So, it's a element of the set of reals. It's a funny looking E.
What is the arm of the
right? Because I just said that. That's how you can show a set of real numbers. It's supposed to be bolded, but it's very difficult when you're writing to do bolded. So I do 2 lines.
Okay.
You can just do a capital R. It's fine. So function, no. Okay, domain in the next one. So basically you can get part of these set up without even knowing what you have to do, right? Now this is a line. Take a look. Those are arrows. They're not points. So this end, it's going down and to the left, and this end is going up and to the right. So if I'm saying left and right with no gaps in between, it's all real numbers. If I'm saying down and up with no gaps in between, it's all real numbers. So any line like this that has arrows on both ends, that's a diagonal, is the easiest you'll get. It's just all real numbers for both. Yes? Yeah. Okay, so all real numbers for both of these. Okay. And if you did a vertical line there, it is a function, right? It will only touch once.
Yes.
Okay, next one. Notice how it's not X's and Y's. It is A for your independent and W for your dependent. So when I set up my domain, I'm going to have A. When I set up my range, I'm going to have capital W. So just use whatever variables are in the graph. Take a close look. Take a close look at this and notice how there's no arrows on the end. So this is an endpoint and so is this. So if you start reading this graph from the left, the first point, the first A value that you get is this point here. And that's 10. Then you follow along, it's continuous. So you follow along until here, and that's the last endpoint. So you need to look at the scale, that's going to be 45. So it's going to be every A value between 10 and 45. If it's continuous, then you use that inequality with those boundaries. So basically between here, 10 to 45, and my A goes in between, right? You're putting them in order and you show your inequality. And then A is an element of the set of reals. Okay. So you're doing those 2 boundary values, 10 to 45. Vertically, be a little bit careful. You start from the bottom and look up. The smallest W value is 30. And a lot of you will look at this endpoint here and say it goes between 30 and 50. Do you see any other points that are higher than 50? 60. Yeah, 60. So it's not necessarily going to be the endpoints that give you your domain and range. So you look up here, the highest value. So basically, you can use your fingers if you need to, or your hands in this case, and squish it in. Where do you get? Well, you get from 30 to 60. So that's your inequality that you're going to have for this. So between 30 and 60, and this is for W. Fill in with your inequalities, W element of set of reals. And that's a function, right? It doesn't, although it gets kind of steep here, it's still slightly slanted, okay? Same over there. So it's still a function. Okay. If you look at the next one, it's kind of different. So here, so if we look at the domain, notice how if I go from the left, there's nothing until I get to -4. If I look from the right, there's nothing until I get to -4. Every point on that has an x value of -4. So only one value. So you do not have to actually here put x equals. You can just list it, -4. Okay. Yeah, you don't even have to put that. You just list the number. Okay. What are you doing? Okay, we'll just leave it. Okay, now range is vertical. So if I start from the bottom, take a look, the arrow's going downwards. So it's going to -infinity. If I go up here, the highest value is close to 5. It doesn't include 5 because it's got that open circle. So it's going to be 5 without the equal sign. So this is going to be y is less than 5 for that one. So this one, I do need to have all values of y such that y is less than 5. Okay. And it is a vertical line. So there's an infinite number of points if I put my pencil on that. So this is not a function. Okay. In E, so domain and range, domain. So this is x and y. And this is what we call, in math, we call that an ellipse. It's an oval shape. It's kind of a squished circle. It isn't y equals mx. It's a different equation, yeah. So here, take a look from the left. That's your leftmost point. This is your rightmost point. So what are your x values? Your smallest is 0. Your largest is 6. Okay? Try to always put them in order. Some students like to go from highest to lowest. Try to put them lowest to highest. It just makes it easier. And the inequality signs have to go in the same direction. Sometimes students put them facing the x, and it's like, that doesn't make sense. Then y, if you look, you start going up this way, the smallest y value is at -3 and the largest one's at 1. So y, where y is between -3 and 1, oh, sorry. Y element instead of reals. Okay. Oops. All right. Another application question. So take a look at this. This is S for speed and T for time. So domain is going to be S. I'm going to use a written S so it doesn't look like a 5. And range is lowercase t. So this graph has what we call asymptotes. You're going to learn a whole lot more about them in Math 20. But, pardon? The equation?
The function.
The equation of what? Which one?
The over. The ellipsis. Is it a function?
It's not a function. Oh, yeah, sorry. I thought you meant what's the equation of the function. No, it is not a function. I forgot to do that. Because for every vertical line, there's 2 points, except for the ends, which have 1. So no, that's not a function. This one here has what we call asymptotes. So basically, it says here, it's hard to tell, but that graph doesn't actually touch each axis. So we often show that with a dotted line, and the dotted line is what's called an asymptote. And so that means the graph gets really close to it, but never touches it. Think about it. As your speed is increasing, say there was no limit to how fast you could go, right? There is still no way that you could get to the time that it takes you to get somewhere in no seconds, right? We can't have, it's not Back to the Future or whatever that show is, right? It's not where you can skip time. So this will approach an infinite speed, but that will approach 0 for time, but never touch it. Same thing, if our speed is really slow, our time to get somewhere is going to keep approaching infinity. It's going to take forever, right? But it doesn't mean that for a speed of 0, we're going to get there in any time, right? It's not possible. So these are called asymptotes. So basically, all that it does is means you don't include the equal sign. So for S, our values are between 0 and infinity. So that means S, oops, well, I'll do it in blue just a sec. That means S is greater than 0. Okay, no equal sign. And then T is also greater than 0. Oh, I used that again just a sec. Okay. So if there's a line that the graph approaches, then that means we just don't include the equal sign to it. Okay, so turn to number 6. It says you try. State the domain and range. Oh, I forgot to do this. This is a function, yes. Because that, even though it looks like it's almost vertical, it isn't. Okay, so here in the you try, state the domain and range and whether it's a function, use the appropriate variables. So you do that. I'll put them up in a minute, and then you can start on the practice and the textbook one. Question 6, the you try questions. Just always look at what variables are being used. So for domain, in this case it's t, and it's continuous. And for height, it's h. So we're going to have inequalities, right? If it was just points, we would list them. So here, there isn't even any points or a graph shown that are less than 0. So if you take a look at the leftmost point, it has a time value of 0, and the rightmost point has a time value of 4. So between 0 and 4, and then from the bottom up, then that's between 0 and 80. So that's going to be 0 and 80. And that's h. Okay. Always look at the scale. Sometimes the applications, you have to be careful. Maybe that end point is between 2 numbers. So take a look. Is it halfway between? Is it 3.5, 3 1/4, or whatever? So be careful. This is okay. And vertically, it just touches once, as I move my vertical pencil along. So yes, that's a function. Okay, now domain, if you look from the left, again, look where there's arrows. So this is going up and to the left, so it's going to negative infinity. From the right, it's the biggest value of x is 2, and it's 2 for all of these points. It's less than 2 on this part. So basically, for your domain, it's everything that's less than or equal to 2. Vertically, the range, this arrow is going up and to the left, this is going down. So remember, if I say up and down, and there's no breaks in between, that's all real numbers, because this is going to go down to infinity. So it's going to have y values all the way up here, right? Because this will be out here. So when you go across, it'll have infinite y values. So your domain is x here, and your biggest value is 2, and it's everything less. So it's x less than or equal to 2. And y is all real numbers. Okay, now that vertical part, if I put my pencil here, it touches an infinite number of times, so it is not a function. Okay. All right, so the rest, there's practice there, there's textbook questions, if you take a look. Lots of work on.